Set. Introduction to set. So what exactly is set? Set is the collection of well-defined objects. Now, from the word well-defined, you should be able to know what it means. So it means when you have different objects being arranged in a regular pattern or being arranged in order. So that is what a set really means. Now, what are the examples of set? One of the examples of set is the set of states in your various country. Okay, you should be able to list out the states you have in your countries, and at the same time the set of students in your particular school or college. You should be able to say the amount of students or the amount of boys or girls you have in your particular or various institution. Now, before we go over some basic things like membership of set and so on, there are still some examples of set, particularly used in problem involving sets, that you need to be familiar with. Now, the first one is what we call natural numbers. So what exactly is natural numbers? So basically they make use of a capital letter N. So some will make it bold, so you can make it bold as well. So capital letter N to represent natural numbers symbolically. So this is known as counting numbers. So natural numbers start from 1, 2, 3, all the way to infinity. Now the second one is known as integers. So they make use of capital letter Z to denote integers. So some will make it bold as well. Well, you are still referring to the same thing. So integers, what is integers? Integers consist of both negative numbers, including zeros, and positive numbers. Okay, so integers start from negative infinity, 0, all the way to positive infinity. So example of integers is -2, -1, 0, 1, and 2. So basically that is integer. Now the next one you need to be familiar with is known as rational numbers. Okay, so they make use of capital letter Q to represent rational numbers. So rational numbers are numbers that can be expressed as the ratio of two integers. That is, as soon as we can have -1/2 or -2/4 and so on and so forth, or 3/5. So all these are examples of rational numbers. Okay, as soon as the numbers can be expressed as the ratio of two integers, then the particular number is said to be a rational number. So we also have positive rational numbers, negative rational numbers, positive integers, and negative integers. Okay, the difference between them is that for the negative ones, they are going to be associated with negative sign, while for the positive one, then they will be positive values. Okay, now the next one is irrational numbers. And when it comes to irrational numbers are numbers that can be expressed as the ratio of two integers. An example of irrational numbers, well, in irrational numbers is denoted with capital letter Q as well, but it will be with prime, capital letter Q prime. So this simply equals to, an example is pi square root of 2, then cube root of 4, and so on and so forth. Okay, as soon as we can express integers expressed as the ratio of two or more integers, then that is known as a rational number. So the last one is the real numbers. Okay, so the real numbers is the combination of two, or is the combination of both rational and irrational both rational and irrational numbers. Okay, sorry. So there are most common three ones that they make use of in problems involving sets. So the first one is even numbers. What are even numbers? Even numbers are numbers that can be divisible by 2, such as 2, 4, 6, 8, 10, and so on and so forth. We also have prime numbers. Prime numbers are numbers that can only be divisible by itself and 1. An example of these is 2, 3, 5, 7, and so on and so forth. And the last one is odd numbers. Odd numbers are numbers that can be divisible by 2, such as 9, 5, 7, 15, and so on and so forth. Okay, so make sure you take note of all these different examples, as they make use of it in many problems involving sets. So now let's go over membership of a set. So what exactly is membership of a set? Okay, with examples you will be able to know it better. So let me rub this off first. Okay, so let's say if capital letter A, well, I think I omitted some things that you need to be familiar with. Okay, we make use of capital letters to denote a set. Okay, let's say A is a set, so we are going to make use of capital letter to denote it. Now we make use of small letters, lowercase letters, to represent elements of a set. We make use of small letters to denote elements of a set. And basically, elements of a set are usually enclosed with what we call a coiling bracket. Okay, they are always within a brace, so they will be enclosed with a coiling bracket. So you need to make sure you take note of that as well. Okay, now let's move on. If A denotes a set and small letter B denotes a member of the set A, okay, or we can write B okay, and what does this really means? It means B is an element of A, or B belongs to A. This particular symbol that looks like epsilon, it means membership symbols. We make use of these symbols to show the relationship between elements and a particular set. Okay, so now let's consider the other way around. Let's say A is a set and C turns out to not belong to element in particular set A. Then in order to show the relationship between them using the epsilon or membership symbols, we can say C is not an element of set A. So that basically that is the basic idea behind using membership symbols. Okay, we make use of it to relate set and its particular element. Okay, so hopefully you guys are following. So let's try to work out one example rather. Okay, so we have, if X is a set of all prime numbers, okay, and Y is a set of all even numbers. If A equals 5, B equals 4, and C equals 9, find where A, B, and C belongs to. Now, from what I've taught you earlier, I said prime numbers are numbers that can only be divisible by itself and 1, while even numbers are numbers that can be divisible by 2. So it means for the prime numbers, which is denoted with capital letter X, as the set of X will be equals to 2, 3, 5, all the way to infinity. Okay, so we are using what we call the coiling bracket. Okay, sorry for that. Okay, so this is how a coiling bracket really looks like. So we make use of this bracket to represent set. Okay, so it's pretty fine this way. Okay, so set Y is even numbers, and even numbers are 2, 4, 6, 8, all the way to infinity. Now the set A, element A rather, is equals 5. Okay, now out of the two different sets given to us, where can we find element A? It turns out that element A can be found among the elements in set X. So therefore, we can write A as the element belongs to set X. Now for the next one, which is 4, B, I said B equals 4. Where can we find 4? We can find 4 from the element in set Y. So therefore, 4, which is B, is an element of set Y. Now the last one is 9. Where can we find 9? Now it turns out that 9 is what we call odd numbers and not a prime number, because odd numbers can only be 0 by itself and 1, but we can still use 3 to divide 9. So therefore 9 is not, or C rather, is not an element of both y and x. Okay, so hopefully you guys are now familiar with how to relate elements and sets together. Okay, so let's move on to the description of sets. How can we describe sets? We have 3 different ways to describe sets. The first one is what we call the statement form, and the second one is what we call roster or tabular form, and the last one is what we call the set builder form. So left to me, I think both statement and listed or roster or tabular form are much more easier to interpret rather than set builder form. Okay, let's look into them one after the other. Okay, now let's start with the statement form. Okay, if A denotes a set, now if we want to use the statement form to describe the element in set A, then we are going to state the element in statement. Okay, now what are we seeing in Excel is that, let's say the elements in set A are even numbers. Then in order to describe this in statement form, A will be equals, or is A is a set of even numbers. Okay, that's how it will be. A is a set of even numbers. Okay, so that is statement form. So everything will be in statement. If at all A is a prime number, then it will become A is a set of prime number. So using statement form is not that common in problems involving sets. They make use of both roster or tabular form or set builder form. Okay, now let's move into the roster form. Roster or tabular form, in this method of describing set, all the elements of the set will be listed out. They are going to be separated with commas, okay, and enclosed within a brace. What are we saying? Let's consider the same scenario. We said using the example we used for the statement form, we said A is a set of even numbers. Now if at all we want to use a roster or tabular form to describe this particular set, then it becomes this form: A is equal, okay, all the set or all the elements will be listed out. Okay, we said even number, so start from 2, 4, 6, 8, then all the way to infinity. So that's what we call listed or roster or tabular form. So this is most commonly used. Okay, but at times they make use of set builder form as well. Okay, so the last one is known as set builder form. Now for the set builder form, it is a way of describing a set by stating some properties which characterize the element of the set. Okay, let's consider the same example as well. Now if at all we want to describe this particular set A using set builder form, then we are going to write A as to be equals to 2n such that 1 is less than equals to n and n will be less than equals to 4. Now in this particular method of describing set, you need to be familiarized with some symbols being used in inequalities. Okay, this is what we call less than, and this is what we call greater than. Okay, this is less than or equal to, and this is greater than or equal to. So make sure you take note of that as well. Okay, now just as we have said, this is known as set builder form. Okay, we make some properties to characterize the element of the set. Now we observe that we said 1 is less than equals to n and n is less than equals to 4. It means the value of n will start from 1 all the way to 4. So if the value of n start from 1 all the way to 4, so let's say 1, 2, 3, 4. Okay, so 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. You can see this will keep moving all the way to infinity. Our result will keep being even numbers. Okay, so that is how to use set beta form to denote or to describe a set. Okay, now don't forget we said for the first example that set is a set of even numbers. Okay, we didn't give it a limit, so it means this is going to range right from 1 all the way to infinity. It won't stop at 4. Okay, it won't stop at 4. It has to stop at infinity. It will keep going because even numbers keeps going with no end. It keeps going all the way to infinity. So hopefully you guys are now familiar with how to deal with problems involving sets or how to describe a set using the 3 different methods of describing set. Okay, so now let's try to work out one more example. So now I want you guys to pause this video and try to provide the solution to this particular problem. So let's say C is a set and it is described using a set beta form as C is equal to X such that X is 2-digit natural numbers. Okay, such that the sum of these digits is 8. Let me come again. C is a set, okay, and is equal to X such that X is 2-digit natural numbers, such that the sum of these digits is 8. Now what are we saying in essence? Well, I don't want to write it out so that it won't take much of time, but hopefully you guys have written it down. Okay, what are we saying in essence is that the value of X is a 2-digit number, okay, and the sum of this 2-digit number is 8. Now what are the 2-digit numbers that can sum to 8? So let's start. So the value of set C will simply be equals to 17 because 1 plus 7 is equal to 8. Okay, also 26 will give us 8, and at the same time 35 will give us 8, 44 will give us 8. Okay, you can see that as we are proceeding the value keeps increasing, and at the same time the sum of these 2 digits is still 8. Okay, so 53 as well will give us 8, 62 will also give us 8, and at the same time 71 will also give us 8, and the last one will be 80 and 80 because 8 plus 0 is also 8. So basically that's how to interpret set beta form into a roster or tabular form. So I have some exercise for you guys to practice. If you want me to review your answers, you can comment it in the comment section below, and I promise to reply as early as possible. Okay, so thanks for watching my video, guys. See you guys in the next video. So that's it for this video. Okay, so this is the exercise I have for you guys. Okay, that's it. So we have 3 different questions with 3 different sections. Okay, so for the first one, which of the following are sets? So just comment your answer if you want me to make a review. And the second one, write this following set in roster form. So just list out what they mean. Okay, it is being written in set beta form, so I want you to list out their elements. Then the last one is to insert the appropriate membership symbols in the blank space. I said A is a set of element 1 all the way to 6. Now I give you some listed of options to just say if at all they are members of set A or not. So thanks for watching once again. See you guys in the next video. If you like my video, please don't forget to give me a thumbs up. Thank you once again. See you guys.